Okay, picking up where we left off from the last video. Now at the beginning of the last video I said one of 4 videos. It's probably going to be much more than 4 videos. I'm experimenting with how long I can do each video. So there'll just be lots of videos for each section. You just watch them at your leisure, but before due dates so you get all the work done. Okay, so we had in the first video the concept that limits were about closer, closer, closer. Functional values were exact, limits closer, closer, closer. One way that we're going to further investigate that is to make some charts. Now, charts are great for investigative purposes, but they are not great for finding answers. Once we get to the analytical way to find limits, that's what I'm always going to want. I'm going to want you to find limits analytically. I'm just messing with my phone here because I was trying to set a timer and I didn't successfully do that. So we'll see how long this goes. It'll probably just cut me off at some point, but that's okay. So let's do the charts here. Let's let f of x equal 1 over x minus 3, find f of 3. So f of 3 is going to be 1 over 3 minus 3, 1 over 0, which is undefined. So the functional value in exact x equals 3 is undefined. Now I want to investigate what's going on by looking at some charts here. So over here we have x going through the values 2.9, 2.99, 2.999. These are smaller than x, less than x, so this is going to be x approaches 3 from the left. Now I'm going to plug into my function up there, plugging into 1 over 3 minus 3, and you can trust me, or 1 over x minus 3. When I plug in 2.9 into this function up here, I'm going to get negative 10, then negative 100, negative 1,000. And we're going to make the assumption that the pattern continues. And that's why you can't use charts to actually find answers, because mathematically we shouldn't make that assumption the pattern continues. But in this case, the pattern is going to continue. And so the numbers, they keep getting smaller and smaller and smaller. They don't approach a single fixed value. A limit exists when it approaches a single fixed value, and it's not approaching a single fixed value. So all we can say here is that the limit as x approaches 3 from the left of 1 over x minus 3 does not exist. But that's not the best way to describe this answer, and we always want to give the better answer. And so the better answer, the answer that I'm going to want you to give, is that this is approaching negative infinity. The numbers are getting smaller and smaller and smaller, and so we can describe that by negative infinity. Same thing over here. We got 3.1, 3.01, 3.001. The numbers are larger than 3, so x approaches 3 from the right. Less than 3, left. Notice less and left, both L's. I plug into 1 over x minus 3, and I get 10, 100, 1,000. And we get pretty much the same idea here, that the limit as x approaches 3 from the right of 1 over x minus 3 does not exist, but the better answer, and the answer I want, is the limit as x approaches 3 from the right of 1 over x minus 3 equals infinity. Now, infinity and negative infinity are both types of non-existent. The limit doesn't exist, but we can better describe it by writing the symbols negative infinity, infinity, as the case may be. Now, the left and right are different. Negative infinity, infinity are different, and so all we can say is that the limit as x goes to 3 of 1 over x minus 3, the two-sided limit, does not exist. Left did not equal right. Now, had they both been infinity, we could write that the two-sided limit was infinity. Had they both been negative infinity, we could write that the two-sided limit was negative infinity. And down below here, we've got the graph of 1 over x minus 3. And we can note that on the left here, and I got lazy when I was drawing my graphs, I didn't put little arrows here and here and here and here. That was the timer that I was trying to set that didn't work. over here looking at the right of 3. So I have an asymptote at x equal 3, which corresponds to the function being undefined. That corresponds to f of 3 being undefined. But when I look over here on the right of 3, graph goes nearly straight up to infinity. And that corresponds to the limit as x approaches 3 from the right goes to infinity. And over here on the left of 3, graph goes nearly straight down to negative infinity. And so what I'm trying to get at here is the graphs, the limits can predict the graphs can predict the limits. The limit as x approaches 3 from the left goes to negative infinity, predicted on the left side of x equals 3, that the graph is going down. The limit as x approaches infinity from the x approaches 3 from the right, equaling infinity, predicted that the graph was going to go up on the right side of 3. Okay, next example. And I noticed as I started this, I got my examples out of order a little bit, but that's okay. So now we got a new function, x minus 2 over the absolute value of x minus 2. And again, find f of 2, and that's 2 minus 2 over the absolute value of 2 minus 2, which is 0 over 0, which is undefined. Make my charts again, and so this is x approaches 2 from the left. And when I plug in there, I'm going to get negative 1, negative 1, negative 1. Now, I'm not getting that closer, closer, closer idea. It's just always negative 1, but that's okay. And so what this side tells me, or suggests, is the limit as x approaches 2 from the left of x minus 2 over the absolute value of x minus 2 equals negative 1. Same thing over here as we approach 2 from the right using numbers bigger than 2 and plug into my function. I've got 1, 1, and 1. And that would imply that the limit as x approaches 2 from the right of x minus 2 over the absolute value of x minus 2 equals 1. Well, now we have left and right are not the same. So limit as x approaches 2 of x minus 2, the two-sided limit, all we can write is it does not exist because left and right did not equal each other. Left did not equal right. Adjust this a little bit. And then when I look at the graph here, here's my graph, and we see over here on the left of 2, left of x equal 2, graph is at y equals negative 1, which corresponds to the limit on the left being negative 1. Over here, right of 2, x equal 2, graph is at y equals 1, which corresponds to the right limit. We said the limit as x approaches 2 from the right of this function was 1. That corresponds to the graph. And then we get right at 2. It breaks up into two pieces, just like the limit broke up into two separate pieces, and that there wasn't a two-sided limit. You're only going to have a two-sided limit when both sides of the graph come close to the same point. And these guys are not going to come close to the same point. And then notice exactly at 2, we have the open circles, so there really is no point exactly at 2, which corresponds to the functional value being undefined exactly at 2. And I think we'll conclude this video at this point.